One of the major tools of a biologist is the microscope. And we're going to go through a few of the different types. Definitely not all of them, but we're going to hit the basics. So let's start with the one that we're going to be using in class, which is called the compound light microscope. Now, the cost of a compound light microscope is around $400, so we do want to take care in how we get those things around the classroom. And the reason it's called a compound light microscope is because it has two lenses in the same way that a compound word has two words put together to make one word. A compound microscope has two lenses in addition to a light source. Now, the eyepiece is the lens that you look through. It's called the ocular lens, and ours have a magnification of 10 times. And then there's the objective lenses, which turn on a nose piece and have varying degrees of magnification, going from 4 times magnification all the way up to an oil immersion objective, which is up to 100 times magnification. Now, in order for a compound light microscope to work, light has to be able to pass through the subject. This happens to be a flea on a compound scope, and it's thin enough and small enough that light can pass through it. In order to determine the total magnification of the specimen you're looking at, you have to take the magnification of the ocular lens times the objective. So if I was looking at this flea through the scanning objective, that would be a 4 power times my ocular, which was a 10. So my total magnification of the flea would be 40. Now, there are limits to a light microscope. One of those is the magnification and resolution will determine how crisp the image looks. The higher you go in magnification, the lower your resolution goes. And then the limits of resolution for a compound scope is 1,000 times, so you're not going to get that truly magnificent detail that you're going to get in some of the electron microscopes that we'll talk about. Now, the reason that you can't get beyond that 1,000 is because the diffraction or the bending of light as it passes through the specimen. Here's a typical compound light microscope. Most of our scopes are monocular, which means they only have the one ocular lens. This is a binocular lens. And then you can see the objective lenses that turn about on a nose piece. The stage is where you rest your specimen. There is an opening in the stage for light to come through. You can adjust the amount of light with the iris diaphragm, and then the light source is down at the bottom. You adjust the focus using one of two knobs, fine and coarse adjustments. The stereoscope, otherwise known as the dissecting scope, is another one that we use in our classroom. This one is around the $400 range too, but you use this when a specimen is just too big for light to shine through it. Now, the reason these form these really cool images is because the specimen is illuminated from above, and they can also be illuminated from below, and that bounces back to your eyes and you get this magnified picture. It's not a strong magnification, however, as the compound microscope. Here's a typical stereomicroscope. Now, transmission electron microscopes will not be found in our classroom because they're cost prohibitive and we would not need something this magnified in our setting, but you'll see these in colleges and laboratories. Now, a transmission electron microscope takes a three-dimensional specimen like this blood cell that you see here and slices it into very thin slices, much like if you go to the deli counter and you get meat sliced, the same type of manner. And then the specimen is placed into a vacuum. So unfortunately, because of the slicing and because of the vacuum, you're not going to be looking at living specimens with this particular microscope. And then beams of electrons are focused on the specimen with using magnets to focus those electrons. A scanning electron microscope gives you these wonderful images you might have seen on Google or an advertisement or on television, but here you get to see the surface of the specimen. And these specimens are going to first be coated with a metallic substance and then shot with a beam of electrons, which will then bounce back at different angles and go to a computer, which will then be able to form a three-dimensional image. Now, scientists now can see at the atomic level, and the two inventors of the scanning tunneling electron microscope actually won the Nobel Prize for their invention. But you can see atoms, which is amazing. So usually what happens is you have a very sharp metal tip, and you run that very sharp metal tip over a surface and apply an electric current to the tip or the sample, which can image the surface at a very extremely small scale, the atomic level.